Hey there, everyone. So welcome to the third lesson, the third learning module of the QM topic. We're going to be doing today statistical measures of assets returns, which a long name they gave to this learning module. So basically what we're going to be doing here is learning statistics measurements applied when we're doing analysis of assets returns, right? Stocks and bonds, etc. That's it. So we're going to be, what we're going to have in mind here is what? Means, average, standard deviation, covariance, correlations, variations, deviations, all of those. Those are statistics measurements used in asset return. So we're going to find the expected return. We're going to see how much those returns are deviating from the expectations. What is the risk involved? That's a concept of risk. Right? That's it's the first step of explaining the concept of risk that you're going to see in portfolio management part 1 is here, right? This understanding of those statistics measurements that could be used to represent risk on an investment. Right? So let's see the learning modules. It's a short video here, short learning module, so therefore short video. We're going to go straight to the point. We're going to try to see how those questions would appear in the exam, and that's it. So I'm going to go straight to the learning outcomes. So let's see. First one, calculate, interpret, evaluate measures of central tendency and location. What's central tendency? A mean, median, mode. Right? Location is exactly where on that sum or the value that you got it is in relation to the expected value. What is the position? Right? That we do that in numbers of standard deviations from the mean. Okay. Again, this learning module 3 is one of those that you're gonna need some prerequisites on statistics. Okay, so if you don't know what's a normal distribution, don't know what's the average, you don't know what's skewness, kurtosis, mode, median, standard deviation, deviations, etc., variances, you're gonna need to do a review of the prerequisites. Okay, all right. Second one. Calculate and interpret, evaluate measures of dispersion. Dispersion will be more like standard deviation. How many deviations? Location and dispersion are connected. Location can be done in terms of how many standard deviations that number is from the expected value. Okay, it's a location. Okay, or dispersion is how far that value is from the expectation. Okay, so dispersion, deviations is all the same thing. Okay. On level 2, you're going to see the word squares, sum of squares. Sum of squares is the sum of the deviations that were squared to eliminate the negative numbers. Remember, deviations can go up or down, more or less. But doesn't mean that one is positive and another deviation is negative. Doesn't mean that. Just mean one goes to that way, the other one goes to that way, but the intensity should be seen as equal. In that case, you need to do some kind of, they call a technique, right? To remove the negative numbers. How you do that? One way is to square those negative deviations, right? Or all the deviations. So it's squaring the negative ones, they become positive. Right? So sum of squares or squares can be used to represent deviations or dispersion as well. All right, third one, interpret and evaluate measures of skewness and kurtosis. Now, don't worry about memorizing the formula of skewness and kurtosis. That's out of the scope here. But understanding the problems of skewness and kurtosis, that's important here. Okay? See, take a look again. I want you to see that the learning module, the first learning outcome, there's a calculate on it. Take a look, right? There's a calculate on the first learning, outcome. The second learning outcome, there's also a calculate, but the third and the fourth do not have calculations. They have interpret and evaluate. Okay, so interpret and evaluate skewness and kurtosis. Do not calculate skewness or kurtosis, but explain, right? Identify, interpret, tell me what it is. Tell me the problems associated with this. And correlation of two variables. Again, do not calculate the correlation. Explain to me what correlation. Interpret the results. A positive correlation, negative correlation, a correlation of +1, -1. What is the interpretation? So read the learning outcomes. So the learning outcomes tells you what you need to know. Okay. All right. Let's see the key points here. So we already said about the measures of central tendency, outliers. Okay, dealing with outliers. That's a little tricky. Outliers are the unexpected values. Right, super high, super low. How you deal with that? There's several ways to do that. Okay. One way is to use the harmonic mean, as I mentioned before. Another way is to create layers, right? Or what you call the ceilings and the floors. So higher than this, we don't accept it. Lower than that, we don't accept it, right? So there are some ways to deal with outliers. Okay, you need to know how this is done. Measures of location. Okay, so mean, median, and mode. That's exactly where the location of the, what is the percentage of the data to the left, to the right, things like that. The range is an interval, right? It's an interval. It's from something to something. So where is the mean? The mean is in the middle of this range here, the middle of this interval, right? So the larger the interval, the larger the dispersion, the larger the numbers are going to be from the mean, from the expected. The more the deviation is higher. When the range is small, when the interval is small, then you have a better expectation, right? It's not going to deviate as much. Okay. We're also going to talk about here quantiles, quartiles, right? Deciles. Right? I have some examples to show it to you on that regard. All right. Mean absolute deviation is another measurement of deviation. Take the deviations, up or down, remove the negative signs, get the absolute value of all those deviations, add, divided by the number of deviations, and that's what it is. This is your mean absolute deviation, called MAD. Okay, the mean absolute deviation. Number 8, sample variance and sample deviation, standard deviation. So already explained, variance is the square deviation and the standard deviation is the square root of the variance. We're going to see some examples of that as well. What is a downside deviation? Downside deviations are the deviations below the expectations. What about the coefficient of variation? Coefficient of variation, I think you should memorize this formula, is the standard deviation divided by the mean of a population or sample. All right. What else? We have measures of shape and distribution. Measures of a shape of a distribution is the normal distribution, is the other type of distribution, but I believe it's a little bit too soon to mention those here, so I'm not gonna talk about that yet. We're gonna have another module to discuss precisely the probability distributions. All right, let's finish here the key points with correlation. What is the correlation of two variables? Okay. What is the difference, friends, between correlation and covariance? Right? So correlation and covariance. Correlation in covariance measures how the variables are moving together. So they're moving in the same direction, on the opposite direction, in the intensity that those variables move. The difference between correlation and covariance is that the correlation varies from -1 to 1. And correlation, covariance could go technically -infinity to +infinity, right? And believe it or not, between -1 and 1 has the same, not the same total numbers, and between -infinity and +infinity, because between -1 and 1 you also have an infinite amount of numbers. Anyhow, it's easier to communicate, it's easier to understand, it's easier to work with correlation than it is with covariance. So what it is, I call the correlation is the standardized covariance. If you take the covariance and divide it by the standard deviation of the variables, you get the correlation of your variables. It's a much easier number to work with. All right, so understand what is covariance and correlation, understand the properties of correlation, goes from -1 to +1, that the correlation of an asset with itself is exactly the same, right? And the correlation with A and B is the same with B and A, right? And the limitation of correlation analysis, because correlation, right, that's not a perfect measurement, right? And there's some assumptions involved, so we need to know the limitations of correlation. Now take a pause here, right, and take a look again on all of those points, right, point 1 all the way to point 15, and try to imagine how questions could be asked about each one of those points. Okay, that's a way for you to kind of like guaranteed, or kind of like, you know, increase your chances to kind of predict in advance which type of question you could face in the exam, right? That would give you a more understanding of the topic. So do that, create that as a habit. Go over the key points, learning outcomes, and keep imagining how questions could be asked about that. All right? Good. So now I can go to my points. All right. So we already seen the learning outcomes, as you see there, so I'm not going to repeat. Key points, we already did all the key points. I didn't mention much about the scatter plot, right? I have one to show it to you below. Scatter plot is when you take all the values and you plot and you see if they follow a pattern. Right? So that's what the scatter plot is helpful for. Right? So we can identify some kind of correlation, right, among the variables. Right? There you go. And so let's see those specific points now. All right. So let's talk about measures of central tendency. So think about mean, mode, median. Mean, mode, median. Right? When everything is normal distribution, the mean equals to the mode equals to the median. What is the mean? The mean is the expected value. What is the mode? The mode is the most common value that appears the most. Median is the value right in the middle of the distribution, which will coincide with the mean and the mode if the distribution is normal. All right. Now, how do you deal with outliers? I already mentioned the harmonic mean, but I also can talk about trimming, windsorizing, which nothing more than eliminating the outliers. Okay, higher than this and lower than that, no way. Okay. I want to call your attention about the word windsorization or windsorize, because it's a machine learning common terminology, or it's common into machine learning topics. We're not going to see much machine learning level 1, but level 2, machine learning is quite a heavy topic, and the word windsorization is there. It's just a method of eliminating the outliers. All right, measures of location, right? I said about mean, mode, median, but I also mentioned about quartiles, quintiles, deciles, right? Those are important to remember. I'll have here some examples to talk about quartiles and quintiles. Deviations is a measure of dispersion, already mentioned that. And ranges, right, is like they said, the intervals, or also what we call the interquartiles, which I'm going to show to you right now. All right. So follow me here, okay? I will have, there you go, some images here to show it. That would make a little bit more sense. So let's see. Right now I'm going to focus on this. All right. So I want you to understand what's written here, what you see there, okay? Quartiles, quintiles, deciles, percentiles, but try to understand what's written on this graph here, because that's how your exam, the CFA exam, is going to be reported to you, more or less on this format here. This is called the box and whisker plot, okay? Should be on singular here, because I only have one. Right, the box and whisker plot. So what is it? So you're going to get this little area here, this rectangle in blue, okay? And the rectangle in blue, the top of the rectangle is the upper quartile. Look at that. And the bottom of the rectangle, you're going to have a number there, is the lower quartile. Okay, so and the difference between the upper quartile and the lower quartile is called the interquartile range. Okay, the number right in the middle of that box, the blue box, is the median. Okay, and the whisker, which are the green, not the green whiskers on top, called the upper extreme and the lower extremes, right? Those are the highest value in that observation and the lowest value in that observation. If you applied windsorization or trimming, then the upper and the lower will be values assigned. Otherwise, will be any upper or lower extreme value collected on the data collection on that observation. And on that, oh, where are you? There you go. Good. Get comfortable with that, because you could get a question where you're gonna get to identify what is the median, and they give a bunch all the numbers, and they don't put upper extreme or upper quartile, lower. No, they just put numbers there, and you have to identify the median, or you have to find the upper the range, right? So get comfortable with that whisker box, the whisker box. Oof, I'm mixing up. Okay, all right. Let's see about this one here now. Oh, good. Very there. So this one is another way that the measures of location could appear as a question in the exam. They could give you a bin, like with 20 bins, like in this case, like number 1 to 20, right? And they go from 1 to 20, and then they have lower bin, upper bin, or lower bound and upper bound. Okay, the lower and the upper of that range. Okay, and look at the question that it could be asking you based on this table here. Who is the 10th and the 9th percentile? Right? So each two numbers represents 10% of this distribution. I have 20, right? So each two is represents. If I want to get if I divided this by 10. Right? In portion, if I divided this in portions of 10, each two of those represents, right, one of that. So if I wanted the 10th percentile, right, it's just the first one, right, the first two numbers right there. If I wanted the 90th, I have to go all the way down here, right, and get this 90th percentile, which is the last of the one before the last. All right. What about the third quintile? Well, quintile I have to divide it by 5. I have 20. So each 4 here, 1, 2, 3, 4, is one quintile. Right? Then 5 to 8, 9, 10, 11, 12, 13, 14, all the way to 20. So I have 5 portions. Divided this rectangle here in 5 pieces. Right? And the third quintile is the quintile that's right on the middle. After the first and the second comes the third quintile. What about quartile? Well, quartile I divided in 5 by 5s here, because each group of 5, beings 1 to 5, is the first quartile. Being 6 to 10 is the second quartile. 11 to 15, right? It's the third quartile, and 16 to 20 is the last quartile. Okay, so where is the interquartile range? The interquartile range is between the second and the third. So locate the second quartile, right? That starts here on number 5, and locate the third, right? That's right here on the end of the 15. And that difference between the lowest number and the highest number is your range. And the other type of question you could get is the location. For example, find a position, find the 4th quintile. What is on this number, on this list here, where is the 4th quintile? 4th fifth, the 4th fifth, which is 80%, right? 4th fifth, 4 divided by 5 is 80%. Well, you're going to have to use this little location formula here. N plus 1 times y, y being the 8th percent, right? With the 4 divided by 5, that's the word y. Multiply by n plus 1, which is 20. Plus 1 is 21. So 21 times 0.8, 80%, right? It's 16.8. So it's this number here that we're looking for. What is the range that belongs to the 16.8? I don't know. But I know, take a look, I know that the 16, it's between 65.05 to 67.18. And I also know the 17 goes from 70.07 to 72.21. So what would be the logical number to put there, right? For the for this lowest bound for the 16.8 and the upper bound on the 16.8. To remind you that the upper bound cannot be higher than 70.07 and the lower bound has to be higher than 67.18. Guess a number. Well, look, I mean, let me rephrase that. You don't need to guess the number. There's a formula called the linear interpolation formula that you can do. But I don't advise you, I mean, you want to memorize this formula, fine. But you can use intuition here to get the answer. Look, 16.8 is much closer to 17 than to 16 in position. We're talking about position here, location. Okay, 16.8, the location 16.8, which represent 80th, right? The 80th or the 0.8 location here, which is the fourth quintile, is 16.8. What numbers belong to that? Well, it's a number close to 70.07 because 16.8 is very close to 17. So I would put here 69. Okay, 69. Okay, and here, right, it's a number, right, that's also close to the number 17, but not going over. So I'll put like 70.8. Or here I could put 68 and here 69. Anyway, what I'm trying to show here to you is that you don't need to memorize the linear interpolation formula. If you're lucky, and most likely you will be in the exam, that's my prediction, the answers are going to be very well spaced. Just by looking at the answers, you'll be able to know which ones would be the range for that position 16.8. Okay? Well, in any event, you're going to have a few questions on the ecosystem to try that. Okay? All right. So those are the type of questions that I predict it could be on your exam related to location. All right, let's continue here, friends. Now, let's talk about those specific measurements here. Mean, median, mode, variance, standard deviation, kind of already mentioned to you. The mean is the average, the expected. The median is the middle observation. The mode is the most common. The variance is the square deviations, right? The average of the square deviations, I should say. And the standard deviation is the square root of the variance, right? So it's good to remember, to remind you of that. All right. Now let's talk about skewness, right? And kurtosis, normal distribution. And let's talk about a little bit about the student T distribution, okay? Kind of prerequisites, huh, friends? So bear with me here if this is kind of like a difficult for you. You're going to have to do a review on the prerequisites, okay? All right. Take a look. In the normal scenario, the mean, the mode, right there, the mean, the median, and the mode are at the same position in a normal distribution. But if there are skewness, means that the distribution is not centered in the middle. Okay, this is an example of a skewness right here. You can see that, right? Is the tail pulls more for one side on the other. Okay, see? Here you have a negative skewed right there. Okay, looks like a ghost walking to the right, right? This one here, that's negative skew. Look at the tail here. Goes to the negative numbers. That's negative skewness. Now, when you see the ghost going to the left side, you see the tail, it's towards the positive numbers. So this is called positive skewness. Okay, so if you have positive skewness, then the order of the mean, mode, and median is like that. The mean is the highest, the mode is in the lowest, the median is in the middle. If it's negative skewed, is the opposite. The mode is the highest, the median is in the middle, and the mean, it's the lowest. Memorize that because could be a question. I don't know. Now, skewness is a problem. So when a distribution, a population is distributed, it has skewness, it's a problem. okay? Because the expected values are not going to be exactly as if it was in a normal distribution, okay? So skewness could be a problem. You want to make sure that you have zero skewness on your samples or populations when you are doing the analysis. Now, another problem, which is not the centralization of the curve, another problem is called kurtosis. That's how long the tails are. A normal tail would go 3 standard deviations to the left and 3 standard deviations to the right. That's the normal size of a tail in a distribution. That's called the normal distribution. So that's why we say that the normal distribution has a kurtosis equals to 3, because it goes 3 standard deviations to the left, 3 to the right. Now, if you need more than 3 standard deviations to the left or to the right, you need 3.5, you need 4, 3.8, then you have excess kurtosis. You have long tails. And long tails is a problem because long tails can bring outliers, right? Because long tails means I'm going further on the negative area, right? Then I could bring where I'm further to the left of the expected value. So I could bring some low outliers in that distribution, okay? Now, if you have less than 3, if your kurtosis is less than 3, you say 2.5 to the right, to the right, to the left, and you already have your entire distribution, then you have negative kurtosis, which is also a problem, because negative kurtosis does not include all the numbers, and the negative kurtosis usually has a more flat shape. A flat shape means that there's more dispersion, right, of the data under that curve. Let's see if it makes more sense when I show it to you here, okay? The images. So look at that, skewness. This is positive skewness, right? Know how to identify the positive skewness and the negative skewness. Here is kurtosis. The curve in the middle is the normal distribution. The curve above, it's a curve with excess kurtosis. Take a look at the tails, the blue tail, it's longer. It's going to take a longer time to touch the x-axis, right? On the curve here, on the black line here, it's going to cut, if it cuts the x-axis, will cut sooner because it has less tail. I don't like to use the word fat tails as they use in some of the readings. I like to say long tails. I think that's more intuition behind that, okay? And then look at the red one. The red one is the flat one. The flat one is the one that has negative kurtosis, right? The data is all, there's not a central, right? That's not centered around the mean. It's kind of more spaced out. So it's not good for prediction, for hypothesis tests, for anything if your distribution has negative or positive kurtosis. Now, positive kurtosis, negative kurtosis, positive kurtosis, excess kurtosis, higher than 3, could be tolerated because you have the T distribution, distribution T, which is a distribution that has longer tails, okay? By the way, the name for longer tails is called leptokurtic, right here. Leptokurtic distribution. For the plateau one, the one that's flat, is called platykurtic. Remember plateau. And meso means equal. Mesokurtic is that, I don't know, equal, but it's kind of zero kurtosis. You can see. Okay? All right. Let's see. By the way, put that in your pocket. The normal distribution, the T distribution becomes equal to the normal distribution if you add more degrees of freedom. Put that in your pocket, could be a question. All right, let's continue here. Look at that. So the normal distribution has zero skewness, means the mean median mode is in the same place. If there's positive skewness, this is the order. Negative skewness, this is the order. And please, friends, do not confuse skewness with kurtosis. Two different things. All right? All right, let's continue here. Now we're moving from, see, let's recap very quick. We did measures of location, measures of central tendency. Right? Now we're going to see measures of dispersion, okay? Which is the MED, mean absolute deviation, the variance, standard deviation, downside deviation, and the coefficient of variation. Make sure that all of this makes sense to you. What is MAD? Is the sum of the absolute errors, so all the deviations from the mean, remove the negative sign if there are, add, and divided by the total rare errors, you have the mean absolute deviation. The variance is, instead of doing the absolute value, you square all the numbers. Then you square the numbers, then you add the numbers, divided by the number of observations, if it's the population, or the number of observation minus 1, if it's a sample, and then you have the variance. And then you take the square root of the number, and you have your standard deviation. Okay, standard deviation. Okay. What is the standard deviation divided by the mean? The last one. That's the coefficient of variation. So put that formula in your pocket, or that definition, that the coefficient of variation equals the standard deviation divided by the mean. All right. We'll continue and talk, now it's not a model, not dispersion, but it's like correlation and covariance. It's like, you know, the intensity of those variables together when you don't combine forces. So look at that. Correlation between two variables. Make sure you know how to explain what correlation is. It's how they move together, and it goes from -1 to +1. -1, they completely opposite direction, same intensity. +1, same direction, same intensity. So what is the intuition behind this? Look, if we're talking about diversification, it's better to have zero correlation, or two assets, they have perfect negative correlation, so one go up, the other one goes down. So the portfolio is kind of immunized, right? Now, if there are positive correlation, right, or even negative correlation, so that's not close to zero, the total correlation of the portfolio is not close to zero, then you might have risks, right? That you not perfectly diversified from. All right, correlation, scatter plot. Look, the scatter plot's down here. Those little blue dots that you see here, and those green dots that you see there, okay? Try to see if you can get something out of it. Which kind of information do you get it here? Yeah, let's put a little bit more where you see it. Look at that, okay? That means that the blue dots, they're more organized in a line, and aligned than the green ones, right? So you can see that there's better correlation here. There's some kind of like a more explanation power on those than on those ones here. That's a scatter plot, right? That's what it's mostly used for. All right. Before I talk about the limitations of correlation, okay, which is important to know, let's just put that formula in the pocket, in your pocket here. Those two formulas here. The first one is not necessary. I'm just putting here for exemplification. The covariance of two variables equals the summation of the difference between the variable x and its mean, multiplied by the difference between the y variable and its mean. In other words, you multiply the difference, the deviations from the x and the deviations of y, multiply, then add, divided by the number of observations if it's a population, or n-1 if it's a sample, and that's your covariance. I don't think you're going to need that formula, okay? Now, if you have the covariance and you need to get the correlation, or if you have the correlation and you need to get the covariance, then that formula, I think that's more chances to be in the exam, okay? That formula here is the covariance divided by the standard deviation of multiplied, each standard deviation multiplied. So standard deviation of the first variable multiplied by the standard deviation of the second variable, right? And then covariance of x and y on the numerator. That gives you the correlation. Or if you multiply the correlation by the standard deviations, you get the covariance. Put the formula in your pocket because it's important. All right. Finally, I'm arriving here to the last topic, the last point to cover here. Limitations of correlation. So memorize a couple of those, right? Because that could show up in a question. Which of the one most likely is, or which one of those most likely is not, or least likely is, and an assumption or the limitation, in this case is a limitation of correlation, okay? You're going to get questions like that for assumptions as well. When you see linear regression, you're going to have some assumptions there that sometimes don't make perfect sense, but you need to make those assumptions in the reason to the linear regression to work. Same deal here. For correlation to be meaningful, right? They cannot have those type of limitations here, which could be causation is not correlation. So if every day that's raining the stock market goes down, doesn't mean that because it's raining the stock market is going down, right? Causation and correlation. Outliers is a problem, right? The unexpected large or very small numbers. Linear relationship that's not linear, that doesn't follow a pattern like the blue lines here. Restricted range, so it's a small sample or it's a small number of data. Spurious correlation, when you believe that one's caused the other but there's nothing to do. Time lags and dynamics, right? So when you're talking about the time lags, the time that takes for things to adjust, that could cause an impact on what's perceived to be correlation. And the size of the sample, obviously, right? The smaller the sample, that's pretty much what the restricted range is. Now, when I say about restricted range, if they mean the -1 to +1, that's not really the case, right? -1 to +1 is perfectly understandable. The problem is because -1 and +1, you have like 0.00000 something. And sometimes it's hard to read those numbers, right? So again, that restricted range could be a problem on that, but I don't think I still prefer to read correlations than covariance tables. All right, yes, that's it. Let's just recap to see if I cover everything. Calculate, interpret, and evaluate measure center tendency and location. Check. Calculate, interpret, evaluate measures of dispersion. Check. Skewness, kurtosis. Check. Correlation. Check. So we did everything. So the points here. Yep, all of those. Scatter plot, covariance, correlation. Great, friends. I am satisfied that we cover all the important topics, points on statistical measurements of returns, learning module 3. Okay, so I'm finishing the video now. Again, you know the deal. If you have any questions, right? If you have anything that you'd like to discuss, send me a message. I'll be more than happy to help you. In the meantime, keep the motivation, keep studying. The end of, once you finish watching this video, go try to do some problems on the ecosystem to practice, right? Then check the examples to make sure that you're really understanding those topics. That this makes sense, so you can move on to learning module 4, which will be the next video that I'm gonna make. Okay, that's it for now. Bye-bye.